Hello everybody, I'm Suman Matthews and today we will be discussing Nata Mathematics topics. The topic which we will be dealing with today is Statistics Part 2, and we will be dealing with Bayes Theorem, Random Events, Binomial Theorem, and this is also a part of Grade 12 Maths. How do you learn statistics for the Nata Math exam? Are you having difficulty with probability in Grade 12 Mathematics? In this presentation, we learn how to solve problems on Bayes theorem, random variables and binomial theorem. If you are in grade 12 or preparing for the NATA eligibility test in maths, this video is for you. For more videos on grade 12 maths or more videos on NATA maths, I have given the links to my pages. Do share this video with others. And we will be learning about these three topics in today's video: Bayes theorem, repeated independent trials, and binomial theorem. What is Bayes theorem? If E1, E2, E3 are mutually exclusive and exhaustive events associated with a random experiment, and A is any event associated with the experiment, then probability of E1 given A is probability of E1 into probability of A given E1 by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 by probability of A given E3. So the denominator is the total probability of the event A. And probability of E2 given A is probability of E2 into probability of A given E2 by, again, the denominator is the same as the previous one, probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2 plus probability of E3 into probability of A given E3. And the same applies for probability of E3 given A. Your numerator will be probability of E3 into probability of A given E3. The rest remain the same. Coming to question 1, bag 1 contains 3 red and 4 black balls, while another bag contains 5 red and 6 black balls. One ball is drawn at random from the bag and it is found to be red. Find the probability that it was drawn from bag 2. So the first bag has 3 red and 4 black, second bag has 5 red and 6 black. So let E1 be the event that bag 1 is selected, E2 be the event that bag 2 is selected, and let A be the event that we have a red ball. So probability of E2 given A is probability of E2 into probability of A given E2 by probability of E1 into probability of A given E1 plus probability of E2 into probability of A given E2. Now probability of E2 is of selecting the second bag is half. Probability of selecting a red ball from the second bag is 5 by 11. Again we have probability of selecting the 1 by 2, 5 by 11 is repeated again. Probability of selecting the first bag is half, and probability of selecting a red bag from the first bag is 3 by 7. So simplifying, we get it as 35 by 68. A random variable is described as a variable whose values are determined by the outcome of a random experiment. And given a probability distribution of a random variable, the mean is summation x px, where px is a probability distribution. Mean is also denoted by mu, which is summation pi xi, and variance is denoted by sigma squared, that is square root of summation pi xi squared minus mu squared. Coming to the next problem, 4 bad eggs are mixed with 10 good ones. If 3 eggs are drawn one by one without replacement, find the probability of drawing 2 bad eggs. This is without replacement, so you have 4 bad eggs and 10 good ones. Let x be the number of bad eggs drawn. So we need to find the probability of drawing 2 bad eggs. So your denominator will be, totally you are drawing 3 eggs. So denominator is 14C3. Numerator is 2 bad eggs can be drawn from 4 bad eggs in 4C2 ways, and 1 good egg can be drawn from 10 good eggs in 10C1 ways. So it is 4C2 into 10C1 by 14C3. So your answer is 15 by 91. 4C2 is 4 into 3 by 1 into 2. 14C3 is 14 into 13 into 12 by 1 into 2 into 3. This is an easy method to calculate combinations. A binomial experiment is one in which there are finite number of outcomes. Each trial has only two outcomes, success or failure. And the result of any trial is independent of the results of the other trials. So when we have with replacement, we know that it is a binomial distribution. So in a binomial distribution, let P denote the success and Q denote the failure. Then probability that x equal to r is NCR P raised to r Q raised to n minus r, where n is the total number of trials. Now NCR P raised to r Q raised to n minus r are the successive terms of Q plus P whole raised to n. That is a binomial expansion. Hence Q plus P whole raised to n is called the binomial distribution. Coming to problems, a bag contains 5 white, 7 red and 8 black balls. If 4 balls are drawn one by one with replacement, what is the probability that none is white, only 2 are whites? Now with replacement means we know that we have to use binomial distribution. So we have 5 white, 7 red and 8 black. Let P be the success, which is getting a white ball. Probability of getting a white ball is 5 by 20. There are totally 20, that is 1 by 4. Now Q is 1 minus P, which is 3 by 4, and N is 4 because there are 4 balls which are drawn. So probability that x equal to 0 using the formula NCR 4C0 P raised to R 1 by 4 raised to 0, 3 by 4 raised to 4, which is 81 by 256. Probability that x equal to 2 is NCR 4C2 1 by 4 squared, 3 by 4 squared, because there are P squared Q raised to n minus R, which is 4 minus 2, which is 2. So you get 27 by 128. Coming to question 4, a binomial distribution has n equal to 60 and p equal to 0.7. Calculate the mean and standard deviation. Now q is 1 minus p, which is 0.3. Mean is np, which is 60 into 0.7 because n is 60, so this is 42. Standard deviation is square root of npq, that is root of 60 into 0.7 into 0.3, that is 3.55. I hope this video was useful to you and we learned to work out problems on Bayes' theorem, random variables and binomial theorem. Do subscribe to my channel and share the video if you find it useful. What do you do next? Subscribe to my channel or you can visit my page, and very soon I'll be coming up with 3-dimensional geometry for NATA maths. So that is for the statistics video part 1, sequel to this earlier video. This is the link. So thank you for watching and do send me your feedback through a comment.